Hello, students. So let's try to go for a revision of central force problem. So where we should focus on the central force problem for mainly IT JAM examination. The question of central force problem is straightforward, simple concept based, and all questions are mainly based on little bit calculation or directly ratio type questions or some problem based on some formula. So let us try to revise the whole topic and where we should focus and where in general students are going to do error. So first of all, in a central force, generally force is defined as minus del V upon del R, and it is only in direction of R. So we have lot of properties, hence your force is central. This V is potential energy. So then your torque is equal to 0. Hence your torque is 0. Angular momentum is conserved. And also we can check whether del cross FR, and this is your force, this is also 0. So your force is conservative. So force is conservative. And now we have also this condition that J dot R is equal to 0. That means motion is confined into plane. Confined into plane. So these two things, when angular momentum is conserved, and this thing will just tell you motion is confined into a plane, and hence motion is confined into plane, then you have equation of motion that m r double dot minus r theta dot square is equal to fr, and sometime you can also write that del v upon del r, and the theta part of equation is that m r theta double dot plus 2 r dot theta dot must be equal to 0, and from here we can easily say that mr square theta dot is equal to constant, and this constant value I can put j, and so we have theta dot is equal to j upon mr square. So this is one of the very important thing, and hence motion is confined into plane. The next thing is aerial velocity. Aerial velocity is going to conserve, and that you can easily see that dA upon dt is equal to j upon 2m. So students, we have done all this thing in very detailed manner, but you have to focus on these particular formula. And now we will just go for what is condition of circular orbit for radius r naught. So here we can just go for condition of circular orbit for radius r. We can use this particular formula, and this formula will tell you, let's say r is equal to r naught is the radius, and we can easily talk about the circular motion. So for the circular motion, m r or r naught theta dot square is equal to fr, or you can write in term of potential that is minus del v upon del r. You can easily find the angular frequency, and this angular frequency is omega naught, and this is nothing but I can put theta naught dot, and this value is equal to del v upon del r at r is equal to r naught by m r naught. So there are a lot of problems based on this particular formula. So you can easily use this formula in a very nice way, and then we can go for next level of analysis. So this is the first part, just using the equation of motion, trying to write the condition of circular motion and the property of the central force. The second part of central force will be associated to the V effective. So let's go for what is condition of V effective. So what is our rule and regulation of V effective and how we can use this particular thing. So let's go for a quick revision for V effective or effective potential. So we can just use the energy part. This energy is equal to half m r dot square plus you have, this is your translation kinetic energy, half m r square theta dot square. This is your rotational kinetic energy plus potential Vr. We have theta dot is equal to J upon mr square. You can use J as your parameter into central force problem. So this is one of the big advantage such that J is constant. So when we can put it here, then E is equal to nothing but half m r dot square, and you can just go for J square upon 2mr square plus Vr. And here we can see that I have written energy E. This is kinetic energy, and this rotational kinetic energy plus potential energy can be equivalent to V effective. So we have V effective, and this is your J square upon 2mr square plus Vr. There are a lot of use of this particular V effective. So you can use the circular condition for circular motion for the V effective also. So suppose we have some this kind of potential, and if this is my R naught, then and this is my E naught, then obviously the particle can move in circular orbit, and this type of potential we can easily talk about V effective, and this is nothing but V effective versus R, and for that condition of circular orbit is condition of circular orbit, and that value is equal to del V effective upon del R must be equal to 0 at R is equal to R naught. And if this circular orbit is stable, then you have del square V effective upon del R square at R is equal to R naught must be greater than 0. So this is a stable circular orbit. And here you can use this particular thing and this particular expression of V effective, and you can easily use this particular thing. Obviously, you can also find what will be energy corresponds to R naught. So from here, you can find the R naught and you can find the energy. So for the circular orbit, this translation kinetic energy is 0. So your energy for the circular orbit is equal to V effective at R is equal to R naught, and we can find this R naught from here. So this is application based thing. And yes, if we have bounded orbit other than circular orbit, then obviously this orbit is ellipse. Okay, this is elliptical in nature, and for that, this is just like as a, you can assume the orbit is in one dimension is something like small oscillation. So you can use this as a small oscillation, and you can find the angular frequency all about del square V effective upon del R square. R is equal to R naught by M. And this is for the elliptical orbit. So students are confusing into the elliptical orbit, into the circular orbit. For elliptical orbit, the concept of V effective is very important. For circular orbit, you can use V effective, as well as what you can do, you can also use just the equation of motion, centrifugal force is equal to just external force. So this is concept of V effective. You can plot V effective in a very nice manner. So at least you have to work for the mainly two type of potential. So first potential VR is equal to half KR square, and for that your V effective is equal to something like this. So V effective versus R, you can plot something like this. So this is your V effective for half KR square.